Okay, brilliant. I think that I'm recording, hopefully. Right, so those are the objectives, very simple. So what we need from any one of you, it's if you're able to contribute to the open source repositories that we are sharing, great, or any other repository, that's fantastic. And there are multiple ways in which you can contribute. It's not only coding, but also testing the codes with your data, and probably sharing data if it's not private data, which is very difficult in oil and gas. I understand that. Then we have share knowledge and experience. So if you identify one of these libraries, please let us know. Share your impressions in the Slack community, and I will mention that in a bit. And evaluate and recommend these applications, and also have a look at the tools that might be integrated to commercial softwares, or libraries in Python that might be integrated to commercial softwares. Offer hands-on tutorials and share your code. These sessions that we are preparing here, we are trying to make the sessions as much hands-on as we can, rather than having philosophical sessions where we talk about machine learning and artificial intelligence and optimization and what it is and what it means for the industry. We want to make sure that we hit a problem and try to solve a problem in these sessions. That's the objective. Ask questions when you need in these sessions or in the Slack, because that's the idea as a community that we help each other. And volunteer as well as we grow. If you can contribute by volunteering, organizing, trying to find speakers or organizations that might be willing to speak about their libraries, open source libraries, mostly, if possible, or organizing the Slack and so on. So what do we have so far? We have a Slack community that has over 700 members. And it's growing, lots of interest, and what we try is to share anything that we have first in the community, rather than LinkedIn or other channels. We have a GitHub repository where every session that we do, we are making the sessions public to anyone. And of course, if you are following these tutorials, you're going to be aware of what we are actually trying to achieve with the tutorials, and you're going to take most of the advantage of having a look at the Git repository and trying to reproduce those examples. These webinars, as I mentioned, they are pretty much hands-on tutorials. We try to do live coding as much as possible, instead of showing just code that has been written already. And most of the session, it's uploaded into the YouTube channel. Sometimes we have issues with the sessions. Sometimes the sessions, they don't make it into YouTube because we have technical problems, or there are parts of the sessions that are not completely uploaded into YouTube. So really the people that has the most advantage of the sessions is the ones that are connected to the sessions live. As I mentioned, as you have seen on the post, this is the calendar for the next few weeks. Today we're going to talk about Python and ResInsight. Next weekend we have Reservoir simulation with an OpenSim Python, which is a simulator that it's binded with Python. And the week after, we have exploratory data analysis of both, which is a North Sea asset, and we're going to use Python, and we're going to use also Orange for that one. Those who haven't seen Orange, I think it's an amazing tool for exploratory data analysis, data mining. You can do some machine learning there. It's probably not for big data, but it really helps to understand all these processes. It's a more interactive, doesn't require much programming, and probably it's very good for framing ideas. So we'll do that in a couple of weeks' time. So Any questions so far? Right. All good. Thank you, Ankit. So we're going to, Adolfo is on the background. He's going to, in a bit, join and show you a demo on ResInsight. The first thing that I want to show you is ResInsight itself. This is not a session on how ResInsight works. I'm not going to teach, or Adolfo, I'm not going to teach you how the application works. It's more about what you can briefly do with the application, and then what is the API, so the application programming interface that is available in Python to connect to a web server to ResInsight, which is extremely powerful in particular for Eclipse simulation results, or any simulator that has Eclipse an Eclipse format as an output. It's really compatible with ResInsight. So ResInsight, if there is this is the website, so you can, if you follow that link, it will take you to the website where you can download the application and where you can install also some data samples that they have in there. So it's an open source application, first of all, and actually I have an error here because it's a post-processor. It's a post-processor, not a pre-processor, meaning that once the simulation results are ready, you can have a look at the 3D, you can have a look at the plots of the multiple items that you have in your Reservoir simulation model. It is developed currently by a company. I believe it's a consultancy company that has a branch on software development branch. It's Central Solutions in Norway, in collaboration with Equinor, and this is part of a project that was pushed by SINTEF in Norway, where they have open porous media simulator that is open source as well, and ResInsight as part of the post-processing tool. ResInsight is distributed under GNU library, meaning that anything that you use with ResInsight automatically becomes open source. And you can actually have a look at the source code in GitHub. By the way, if any of you don't have GitHub, just go and make sure that you have your account of GitHub after we finish this meeting, because it's going to be super useful for all these sessions. Running ResInsight with Python, there are a couple of things that you need to be aware. It's very easy to install the API. For me, I have tested it in Windows, and I believe Adolfo probably have tested it in Linux. It works in all the environments as far as I'm concerned. And you need to install pip install RIPS, and I'll show you that in a bit. And you need to install protobuf as well. When you open ResInsight, make sure, and I'm going to open in straight away. Let me, just a second. This screen is blocking my. So I have just a shortcut in my desktop. It's opening at the moment. Okay, so here we go. This is the interface. As I mentioned, this is the purpose of this session is not to show you how it works, but I'm going to quickly load a simulation case. And let me see what do we have here already loaded. So this simulation case, it's I believe it's an open data set distributed by the University of Campinas in Brazil, and it's pretty much a water flooding water flooding case. So very nice interface where you have a possibility to explore your 3D model with different sorts of views. You can also filter the model in different ways by properties or to ranges. And there are, let me see what's going on here. There are a few statistics that are presented here at the top on the model. You can, that's an info box that you can turn on, turn off. And at the moment, what we see here, it's oil saturation properties. Somewhere you see, well, this is oil saturation. And as you can see here, you can select whether you want to have a look at static properties. Let's say you want to have a look at porosity, your area permeability, your vertical permeability in the model, so you can see how the model can be visualized and move around. So if we go to a dynamic property, we can also select, let's say, oil saturation. And as I mentioned, this is a water flooding. We'll see how some of the wells are depleted. We have some injectors in the field. As you can see, there's some sort of a peripheral injection. Although you have some injectors that are a bit in the lower side of the structure. I don't know exactly how the injectors are distributed in this model. It's something that you can have a look in the. You can download the model from the University of Campinas, and you can. There are a few papers about this model if you want to use it. There are different views here, and as you can see here in the about, I'm going to focus on. Let me see where the about is. It's just behind this. Okay. You can see that I'm using version 2020. If you go to a version 2019, you won't be able to use with Python. And the way you know if you're able to use with Python or not, it's going into the bottom message here. So it says Python script server available and running at port 50051. The way this works is it's pretty much setting up a web server, and the web server it's the ResInsight web server is listening to all the Python API calls, the application programming interface. And there is another way in which you can use it. You can use Octave as well. Octave is like an open source MATLAB. It's an open source MATLAB equivalent to MATLAB, but Python became almost like a ubiquitous tool nowadays, and I believe that they decided to develop this Python script server on the back end to really jump into the wagon of Python. Comparing to some of the commercial tools, it's quite capable, and it has actually a bit some extra capabilities that probably some of the commercial tools don't have. Again, I'm not going to show you much about the tool itself, but you can also have a look at summary vectors, where you can extract, for instance, summary vectors for your wells, for your regions, groups, and so on. So let's say you can select your wells, and you can go into the well bottom hole pressure. Okay, you select multiple wells and have a look at your bottom hole pressure, apply, and there you have a plot. So it's and it works with multiple cases. So that's a bit of a brief introduction to ResInsight. Adolfo has a demo with the library, and I think I will give you, Adolfo, let me see how I can give you the control.
I think I can share my screen here.
Yeah, try.
Oh,
No,
host disabled
I'll
screen.
I'll I'll make you host, and then
Okay.
later on you'll make you can make me host. Okay. So I leave
Okay.
you with Adolfo, and I don't know, Adolfo, if you briefly want to introduce yourself, and then we can.
Yeah. So hello. My name is Adolfo Rodriguez. Probably you've heard me before here, unless you are new to the community. Um, so I've been working with computer programming uh, all my adult life, let's say, and that's a very long time. And I started working in the early times with computer programming such as Pascal, C, and Fortran, mostly Fortran. And I have experienced all this revolution at the beginning. Of course, it was so difficult to write even a simple code because, well, computers were not that friendly. So the younger part of the community probably don't remember that, but computers were not friendly, and there were no personal computers when I started working on programming. So you had to have a workstation at work, at your or a mainframe, and those things were really hard to to work on. So I'm trying to find my I kind of lost my uh, where is it? So okay, here it is. Mm, so the basically what Python has and you know these things have become easier and easier with all the IDEs that have been developed. I remember in the 90s when Fortran 90 came along and Fortran Visual I don't even remember the name, but it was Microsoft that came out with the first Fortran IDE for PCs, right? So and that was a big revolution. So now we could debug our code, look at our code on the screen, and now what Python means to this world is that computer programming is really easy now, and anybody can start working on very complex stuff very quickly, right? Okay, finally found it. Uh, So let's create a notebook, and what we're going to talk about here is about ResInsight, and I'm going to make a little bit of a demo on the ResInsight Python API, and what this allows is to provide control of your data from ResInsight. You can launch ResInsight and minimize basically the whatever you do on the interface. Sometimes interfaces are great. Sometimes they are in the middle of what you really want to do, right? So I'm gonna start with this import and the AP the RIPS ResInsight API is RIPS RIPS, and that's what the module that contains most of all the APIs that we need to control ResInsight. And what we're gonna try to do here is to first of all launch ResInsight from here. You have two options at this point. You can either launch ResInsight yourself, like this. I can type it here on my, and then I can have an instance of ResInsight uh, already already running, and then I can minimize that, and then I can ask the using the RIPS API to find that instance. If it doesn't find the instance, it will launch the instance for you. And this is the password I have installed my ResInsight. If you have it in your environment variables, you don't need to even specify the whole thing. But I don't have an environment, so I will try that later. I execute that, and then it found. It says trying, but it actually found it. But I guess there's something wrong there. So to do that, they should give you a message that has been successful or something. Let's try to load the case, for example. And now it's loading the case. You see that the icon here is blinking, letting you know that something has happened. If you open it, you see that the case has been loaded. And as you saw before, I didn't have anything loaded when I first launched the API. I mean the application. So this is, to me, this is useful. I don't like menus, so but you may like them. If you wanted to open this model, you would have had to go to import Eclipse cases and search it on your browser. So on your computer. So to me, yeah, this is already something that I can certainly use, because sometimes I may forget. I mean, I may know this exact path, but I don't want to, be finding it. But that's me. And now I killed ResInsight, so I'm gonna try to execute this box and see what happens when ResInsight is not open. It's gonna try to find it in all the ports available. I couldn't find it, and then it did launch it, right? Trying to launch. Again, it doesn't specify that it was successful, but I know it was because here it is, right? So in this case, the application was launched directly here by using the API. Now I can, you see there's nothing here, right? And by the way, the model I'm using to run this example corresponds to Brush. Brush is a open, publicly available model. Is synthetic. It doesn't correspond to a real field or anything, but it has been used mostly for uncertainty analysis and history matching examples. It's a water flooding problem. And you can see I loaded it again. Now it's there. And I can now check, for example, water saturation. I can rotate this here. Say I remove the grid, and then I can see the changes in water saturation. So this is similar to what it's a little bit slow. I guess it's because I'm sharing the screen, so it doesn't respond so quickly to whatever I'm doing here. Okay, oh, maybe it's something else. Now it's working. So now you can see that this is a kind of interesting model. This is a big aquifer here, and you see a large number of injectors, in the aquifer area to push the oil towards the producers, which are, located there. You see, the producers are basically labeled with a P, started with a P, and that's what helps you. And of course, you can see also the arrows, typical representation, and of course the colors. Okay, but that's this is very powerful. You can do many things. You can click on a cell, and then you will see the plot happening here. I mean, whatever dynamics is happening there, whatever property you have selected there, you see the changes there. You see the behavior in time, right? And then you can also go to the plot window and have the summary and either field level properties like that, or you can see well level to. I clicked in the wrong. Okay. Also well level. This is a really nice interface, but it can very easily become really complicated. If you want to create a new summary, you go here, and now you have you know, all the fields here. If you want something at well level, then you click here, and all your wells are here, right? You see, the convention, the typical convention is to start with an I for an injector and P for a producer, but of course it doesn't have to be like that. These names are just random names that somebody chose, right? So it can be any name, and sometimes wells can change also from producer to injectors, and actually the name that you give to the well is just a help for you, but it doesn't have to be taken as such as an indication of what kind of well is. But typically, and this is one of the issues, right? When you see here and you click on a say a well that is a producer, basically you have all the properties, and then you even have a water injection for doesn't make sense for a producer, right? So, and things like that. So it doesn't help you to understand what kind of properties you should be plotting. So you know what you need to know what you're doing, which is always useful, of course, but you want the interface also to help you. So I'm not gonna go through this too much because it can become really complicated. And also the people developing ResInsight, from time to time, from version to version, they may change things, the way things show. And also if you work on Linux, like I do, and then you go to the Windows version, you will find that it's not exactly what you were expecting. So that makes things a little bit tedious sometimes. And certainly you would like something that you can control more, right? But for me, if I'm investigating something, I want having an API is something fantastic. So I loaded this case, and you saw I did it on the Jupyter notebook. Now I'm gonna load as well from that case, from this project. I'm gonna load the summary, and this is the way you do it. You need to load the spec, SMS spec file, where you have all the information, and then you give a name. You see that when I created this instance of ResInsight, I name it W. You can name it whatever you want. I just chose W for whatever reason, and now I basically creating a project based on a case which is corresponds to Bruges, and the way you do it is by providing the egrid file. I'm not sure if you can do it with the summary, but typically the egrid is what you use to load the case, which is the grid, right? That's the name. You can see the name indicate. Now I'm gonna load the summary, and now I have the summary here, and this is a tricky part. Now let's assume I want a particular vector of property of results, and then let's say the field production rate or whatever. And if you go to ResInsight, these are names. I know my memory is not that good. Typically, I don't remember things like this. Right? But Alejandro knows this by heart. I always need to look at this so I can remember what these fields mean. And these are very self-explanatory. F means field, and then you have G for gas, L for liquid, O for oil, and so on and so forth. So if you don't have anything, probably it's total. So this is field production. And correct me if I'm wrong, Alejandro. So and now in my FPR, and also I can grab the time as a vector. The times.
That's pressure.
Oh, pressure. Sorry, that's reservoir pressure. Actually, yeah. Yeah. Production requires a kind of a phase, right? If you're thinking of production, you need a phase. So if it doesn't have a phase, typically it's pressure. But you know that's how I work. So I got the pressure here, and this field contains the pressure now, and the times I capture them also in very similar way, right? So it's like time is a behavior. Now I can see, for example, time values. And that's how you see, it returns, when you see values, it returns a list. Something that I don't particularly like. I don't know why they didn't choose to return as a NumPy array. But so they return a list. So it's good to keep in mind because lists behave very different to compared to NumPy arrays. So of course, if you want a NumPy array that contains this, you can always say FPR. Let's call it NP equal to. Oh, I'm not importing NP here. Okay, you have to import NP, which is always useful. Let's import NumPy as NP and import pandas as PD, which is the usual names. You don't have to do it this way, but it is the most useful. And then you can always say np.array. And now this contains a NumPy array, which I think is if you're working with numbers, arrays is much better to use NumPy rather than list. So times, if you want to see the times, these are the times. If you want to, yeah. So I actually made a mistake here. So this should be the times. And if I want to do this with NP, well, you do the same. I'm not gonna do it here. Okay. So again, FPR values, pressure values are this, and now I can do something like import matplot lib .5 plot as PLT, and in the case of matplotlib, you want pyplot, and you need to import as PLT because otherwise it's going to be very messy. You can carry NumPy everywhere you go, but you're not going to carry matplotlib.pyplot. It will be too much to type. So PLT is a universal convention. And now you can do PLT.plot. And then times dot values. It can be either list or NumPy arrays, and that's what you get. So you can go to the interface and check this. If you wanna, you can put a marker equal to, so you can see the actual data entries, and then the line is just a linear interpolation that Matplotlib creates. Okay, right there. Now you have a more flexible, something that you can control more. At least I like this way, and it depends on the particular purpose that you are trying to that you have in mind, right? Because if you go to the interface, you can create that same plot. Basically, I choose FPR here. If I find it, okay. You see, that would be that particular plot. And this is something that for me this is already very, very useful. So let me see, for example, what happens if you want to work with wells, right? Typically wells have names and properties, and they have some status and so on and so forth. You would like to know. You can also grab the simulation wells by typing this and now sim wells. Let me write. Let me show a simple one. For example, let me see the name of well 0, and then that's I1. Right? If you go to the interface, you remember here in my summary plots, if I say new, yes. If we choose wells, you see that the I1 is the first well here. Now let's see all the wells and the status at the time, and then you have to, when you do this status 0, this means the first time step. NW, okay. I need to capture the total number. You know, I can do len, but it's better if I use a variable to. And here you have all the time, it says producer, right? And we know it's not the producer, but I guess this one is simply not active, it's not open. So it doesn't matter if it is a producer or an injector, so it's not simply not open right now. If you go to a different time, let's say 10, and then you will see that the well is already open and it's a water injector. Once it's open, now the information that you get from the status is more accurate. So already something here that you can do on the using the API that will be kind of hard to get it from the interface. So you already know this information, right? So, and then let's take a look at the time steps to see how they produce them. So the particular time steps is notified. Let me see where. Okay. I need to grab it from the case. And then let's take a look, and again it's a list. I think it's a reason they use list instead of NumPy arrays is because probably something like this you cannot use a NumPy array for this. Or you might, I'm not too sure. So I guess lists are more universal. You can use a list for anything, even if it is you know a function or any kind of object, you can put them into a list. But NumPy arrays are only for numbers. So it's your responsibility to decide what you want to do. This API always returns list. And then you can see the dates. This is also something useful. The particular time steps. Now, I already plotted that. Let me see what else I have here. So something I would like to do, something very useful is to interpolate data, for example. But before I do that, let me show you how to do wells. Oh, let me see what I want to do. Okay, let me try this and show one example with wells. And I have this here. So this is the way you work with wells. So you start with a property, and typically the properties for wells start with a W, right? You will know that second letter is the phase, and then you will be injection rate. And this is the way you capture that vector. And probably we want to use something like this, like 2 IR, and then put this here. Summary case, okay. Let me see what's. Okay. And it's because I have different definitions, and this can be an issue when you work with Jupyter notebooks. They can become disorganized because probably you define something on a different cell, and then you lost that cell it's not in your site anymore, and then so this is the injection rate for well I2. And then you can also plot this. What was the name I gave it? I get to time times values. And then I2, and that's that. And of course, it's useful to put a marker. And that's an injection. You see that it starts at 500 days in the third time step for this particular problem. I don't know how long I've been talking. Let me do something that I think is very very useful. Let's assume that I want to work with a limited set of vectors, right? Let's say that I only care for these particular vectors, and I'm not worried about anything else. This could be very useful if you are working with particular wells, right? And then you want to investigate the behavior of those particular wells, and then you can define those vector names, and those are the ones that you're going to be working on. And let me okay, let me do this. Let me create an empty data frame. And now I have that empty data frame, and I'm going to put I copy the wrong all those vectors. So I'm gonna grab the data. You see, I'm gonna look on vector names that are in vector names. Vector names. This is very useful in Python. This is very Pythonic. So if you have a list, typically it's a plural, and then you loop like this, right? And then I grab the data for that particular vector name. I grab the time steps, which probably I don't need the time steps inside the loop, right? So I can put the time step outside of the loop because I don't want to repeat that calculation, right? And then basically what I'm going to be doing here is assigning column names for each one of these vector names. If I show and I can show the full data frame because there are not too many entries. But most of the time when you're exploring data frames, it's more useful to explore the head or the tail. So the last 5 by default, or the first 5 by default with the head. If you want 10, then you can do 10, right? But many times data frames contain hundreds of entries, so you don't wanna explore the whole data frame. You just wanna see that you are getting what you are supposed to have, right? So let's do something else. Let's create a field with the dates. And then this is something else that provides the API. So I get the time steps, right? Oh no, this is samples. I don't have the sample yet. Oh no, I created the sample here, but well, okay, well, I got ahead of myself a little bit here. So there is a way to sample, resample the data in ResInsight, because in many cases you don't have enough values, right? And the values are very coarse. Right, you're jumping 1 year or something. So they provide a way to resample the data. If you don't provide anything, it returns exactly the same vector that you gave as an input. So this is actually not doing anything, even though my field is called sample here. So let's finish this. Okay, I need to import time. And now I can do this. And now my dates, look at what I got with my dates are this way. So these dates are not exactly, I mean, they are exactly the same separation between them, but the starting date is not necessarily the one that you were expecting. And this is something I need to investigate how, because the time steps here, they don't have, even if we go to the interface, we see that well, actually, it actually, yeah, it captured the right date from the API automatically for you. If you see, so the API knows that the initial date is 2000, January 2000, because if I look at the time steps as you saw before, well, yeah, the time steps are not correctly here, but somehow when you sample the data, it sets the right dates. So this is something that the API does automatically for you. So what else I have here? Now I can use this. I can add these dates to my data frame. So I can say df. Let's call it date, and let's say dates. And now let's explore my data frame, and then you see the date is over there, right? And now, I guess something that could be useful. I think I have time steps. Let me see. Oh no. Well, I guess this is fine. I already have the date, and this is this index here because any data frame have the index as the first entry. Sometimes it's useful to have the date as an index. It's up to you, but that's very common, especially for time series. It's good to have the data as an index. But let's do something else. Let me copy this, and then let's try to resample it in a different way. Let's copy this one, and so I don't have. Let's change the name here and put a Q, and then put QR3. Let me create a different data frame. And I'm improvising here completely. This is departing from what I have prepared, but I guess it's useful. Frame. And sample data, this should be this, and this should be that. Okay. Now, if I explore this, now I'm not sure if this is quarter, perhaps. Okay. Quarter means every 3 months, right? And now you have the data every 3 months. Let's create the date as well. And now remember that I put a Q here. Let me copy this one. And this is fine. Doesn't matter if I use the same, let me see, dates. Oh, sorry. Okay, you see that now you have data every 3 months. And now I can say my quarterly data frame date is equal to dates. And now I can explore my data frame again. And then there you have it. So this is much nicer. Now, the other thing that you can do, because this date here on your data frame is just a string, right? It's not an actual date as such, but you can convert it to yeah, you can say, let's say the F Q. Oh, I think I need to import. No, so the data frame pandas already has a function to convert them. So I can say the F Q date, and you want to override it, the column. You don't want to keep two columns with dates, one with strings. And then I copy this one to. I have no. This is not the way. It has to be pp to date, and then I copy this one. Hopefully this will work. To date time. Okay. And now let's explore this again to see what happens. And now this is an actual date time object and not the string anymore, which means that the date time object has a completely different properties, and you can manipulate it and compute, subtract it, for example. You can do things like this. If it is a date time object, you can do things like this. For example, let's say this is, you wanna, how long it has passed between, two consecutive dates, and then you get that. You get 91 days. But if they were strings, there's no way to do this. So, and also the other thing that you can do is plt plot. Let's say my x will be the f. Let's plot the previous. Oh, I don't have the date. Well, let's do it. I guess if I do. Well, okay. Let's say x is equal to the f q date, and y is equal to y. Well, I can do that very quickly. I'll do that in a moment. The f q. One of these properties now, right? Let's say FPR, which is something I've already been looking at. FPR. Well, I guess. Okay. And then let's put the marker. And you see that you have many more points now. Now, to tell you the truth, I'm not sure how. I mean, this has been resampled. You have many more points. Let's put on top of this the previous one without the resampling. but I made the date. I'm not trying to remember if I put, yeah. And then let's copy this one here. Let's remove it. And then let's change, let's not use a marker for the, or let's use something else. And this is what you get. So, I don't know if you like it, but I don't like that resampling very much. I'm not sure exactly what algorithm they're using, but that's what they provide. So an alternative, if you don't want to use what this API provides, is to take your original data frame and use some other package to resample your data in some other smarter way that you can control. But this is basically, of course, you can do these kind of things for any other property. Let's see oil production rate, for example. Copy it here, and then put it here and here, and that will be the oil production rate. And you see the resampling is really ugly, right? So I even prefer my original data. But they give you that option if you wanna play with that. So I guess it's useful. The question is, I'm not sure if they're using a good algorithm here, but you can see what you're getting if you plot, and then you decide if you want to use it or use something else. But basically, my message here, I don't have much more other than repeat this with other properties. So, for example, you can now with this kind of API, you can, for example, look through your wells like this, right? And grab a well according to the properties or something and decide what you are going to plot, for example, right? Because as I mentioned, when you go to the interface and you choose well I5, it shows all the attributes of that any well can have, including many that are not possible for an injector, like oil production or something like that. And then you can with your API choose and decide what you are going to specifically use for each kind of well. So this gives you a lot more control and honestly, this is something that we discovered very, very recently that is available in ResInsight. I've been using ResInsight for years. And this API is something relatively new that they developed. So I think I see myself using more the API rather than the GUI. But I know that I can, move back and forth from the GUI to the API. When I want to have more control, then I'll use the API from Python, and when I want something more visual and more exploratory in nature, I can use the GUI. But definitely having the API is something that gives tremendous power, because now all your data generated by Eclipse or any other simulator with the same output, now you can use. Imagine that you have thousands of cases and you want to do some statistics. Definitely you want to do this from Python, I guess. So something I suggest, I don't have more Alejandro has some more examples. I suggest you, and I'm gonna publish this notebook on GitHub today. Probably I'll publish it as it is, so you can see exactly what you got, what you saw here. And then I suggest you to continue doing other things that you think are useful and interesting. And now you can also we can provide the outputs. So I think many of these outputs you can get from the Equinor GitHub. So we should share that site as well, because they have many examples, including the results that you can explore with. These particular ones were generated with our own simulator at OpenSim that we have developed, and that we will be talking about in the coming session. And just to give you some heads up on that, this is a simulator we wrote in Fortran and use a procedure called binding to create Python, so you can access all the calculations from Python. And you will see, but all these packages like NumPy and Pandas and so on and so forth are really done in the same way. So on behind is actually C and Fortran, and then you have accessibility from Python, and that's what gives the power, because now once you have a Python interface, and the same is true. The same is true with ResInsight. ResInsight was written in C++, and then you have all this access from Python, and you can see how you can bring something that can be very obscure and difficult to combine and difficult to integrate with other tools. You can bring them those applications to Python by doing bindings, and now you have the possibility to use the whole Python ecosystem to along with your application. So that's a powerful concept that I think is the fact that has made Python such a incredible tool, because you have all these existing tools that you can bring them to Python by doing these bindings and creating APIs, and now you have Pandas for data analysis and scikit-learn for machine learning and so on and so forth available. And that's what I have. I don't know if you have a question. I think Alejandro is going to continue with some more examples.
Yes, thank you, Adolfo. So let me see if I can regain the host, or can you promote me to host?
Can I? How do I do that? This one's interesting. I guess I can go to the list. Find you.
More.
More. And remove.
Make host. Nothing.
Okay, now you're the host.
Okay, cool. So for this part, let me see. Let me share my screen. So can you see my screen?
Yes, I can see your screen.
Anyone else than Adolfo can see my screen? Is there anyone else listening out there?
Nestor said yes.
Okay.
Yeah. Okay. Natalie, many people are saying yes.
Okay, awesome. It's good to know that people is still
alive.
Yeah. Right. So just let me see where this is a bit okay. Let me see where we are at the moment. We have seen the most of the functionalities or part of the API to ResInsight, and I'm going to show you a bit more examples. So, for example, we go into exploratory data analysis. Well, not exploratory, a bit of exploratory data analysis into one of the models that I have. In this particular case, I'll show you how I'm going to do some analysis into the data of this model, the UniSym model. So extract some grid information, well information. We're going to extract some 3D results and some static properties to do a bit of exploratory data analysis with the static properties, such as histograms, cross plots, pair plots in general. And then I'll show you a bit of interactivity with ResInsight. So what you can do in ResInsight and how it reflects back into Python, and how you can calculate properties from Python and push it into ResInsight. And at the end, I'll show you some examples of handling multiple models, which is using summary vectors, similar to what Adolfo did. I'm not going to go to all the explanation. Of course, Adolfo lay out the foundation for most of what I'm going to show you here. So exploring the model, and let me set up everything on this side. As Adolfo mentioned, you need to import your libraries first. I'm importing here, apart from RIPs, I'm importing pandas and NumPy. And datetime is quite useful, as you will see later on. Matplotlib, and I really like Seaborn as a plotting alternative as well. So in terms of exploring the model, the first thing that I'm going to do, it's because I have already an instance that it's open here. So in fact, yep. So I'm going to just define ResInsight, or I can call it whatever variable. Let's call it ResInsight. So from the library RIPs, if you have a look at all that is available in the library, we're going to load instance. And we're going to load from instance find. So once you have instance find, it's, as I mentioned, as Adolfo mentioned, you have the connection to the port. I'm going to get all the cases. And if I do ResInsight dot project dot cases, you'll see that there is an object here that it's a ResInsight object which contains the cases. So I have only one case, which is the one that you've seen here, the Unisync model. And so if I go to case 0, and that's my simulation model. So for that case 0, if I want to get the time steps, I'm going to get the time steps directly, time steps, and dot time steps. I'm just using tab to help myself understand what I can do, and this is a function. And if I print the time steps, again, here, you will see what are the time steps. Now, this is the time steps that are, of course, related to the grid, to the solution, to the restart case, to, the 3D solution, and also to the summary as well. So let's do some analysis, and I just want to print here what is my first time step, and I'm going to use date time to convert that first time step. So if I want to access the first time step, it's if you see, this is a list, so a list of year, month, day. Then there is an item 2, item 3, and so on. So I'm going to get from item daytime date. If you see the manual, it provides. Let me run this. Right. So at the moment, it's loading the libraries. As you can see, Python, it's working on loading my libraries. So daytime, don't know why it's not coming. But if I do time step, I can access year, and then I can do again time step 0, and I'm going to get a month. And time step, oops, went outside. and I'm going to get the day here, close. So I have start, time step is not defined, time steps, I always make that mistake. Right, so I've got my start date, and I want to do the same for the end date. So anyone have a hint how to do the end date? Let me see the chat, if see if people is paying attention. And so I have a chat. Exactly, Farouk, thank you, Farouk. So for the end date, I'll do -1 to get from the list, the final item of the list. And just going to print start. So what is really powerful of this is that once you have all this script, you can almost think as your own notebook where you can explore any simulation case that you have. So the more time you invest on developing this notebook, it's a notebook to do a quality control. Yes, you can import history matching, but not history matching quality. Production, you can import production, but the history matching, there is something else that I do on consulting. We have our own library for consulting where we calculate the history matching objective functions, and we also read summary vectors, not with OPM or resin, sorry, not with ResInsight or libECL, but ResInsight doesn't offer history matching quality straight away. So now I have this couple of vectors. So I have end. So let me do some start date is the following one, and I would like to print the end date. So again, it's a bit of setting up a bit of your exploratory data analysis on future cases. And the other thing that I want to do is get the grid information. And for that case, 0. Now what I can access is grids. Let's see what happened here with this grid. Again, this is an object. And as you see, it's within a square bracket because you may have several grids. So if you want to extract what is inside, I'm going to extract the item 0 of that list, which is this object itself here. And now I can get the dimensions. Of course, you can do all this visually in ResInsight, but imagine that you want to do this for another for a lot of models, or you have your own dashboard that is extracting data from your simulation model, and you can also do that. Okay, there's someone. If you can unmute yourself, please. Okay, I think I mute the person. Right. So then one thing that I can extract from the grid dimensions or from it's also cell count. So more properties from that case 0. I'm going to extract now the cell count. Again, I can tap, and if you can see all the properties you can extract from the simulation model straight into Python. So let me print here my cell count, and also here I'm going to do a print of my grid dimensions. Grid dimensions, and what I'm going to get is from dimensions, you can get I dimensions, you can get J and K. And for the last thing that I want to print is, let me see how this is ongoing. First, I have a start date, end date, grid dimensions. That's a 79 in I, 55 cells in J, 35 layers. And I have almost 60,000 active cells on this model, or out of 150,000 total cells. Probably almost 90,000 cells are inactive. And last that I want to show you, I want to print again, the cases. I'm going to show you what are the available properties. So the available properties. And this is something that I think Adolfo didn't show this because this is on the grid. You have to specify whether you want the dynamic. And it's funny, you have to put dynamic _ native to get the dynamic data. And you have in this model pressure, RS, gas saturation, and so on. That's all you have in that model. And for static, I can do static. And there we have many more variables here. So a bit of setting up quickly an exploration for my case. And the next thing that I want to do is extract how many wells do we have here. So let's put all the wells in a let's call it a wells object. And I'm going to put all these wells in, for the first case, simulation wells. And if you see this object, it's it has all the wells, but as you can see, it's a list of objects. So we don't have a name of the wells or any information straight out of the list. So we have to extract the information. So the way I would do it is for a wells object. I'm going to extract. First of all, I want to extract the well name. So I'm going to generate a list of well names. And from every item in this list, I'm going to get my well name. So if I do this, if I print this, you see that I can get the well name. So let me append, store all the values in this list. And now if I show you the list, I have everything contained in a list. Now, what else would I like to do? I would like to see where the well is connected and the status of the well, and store probably also that. So if I only do, let's say, let's show the first one. And I'm going to show if, let's say, if well.name is equal to, let's get one of these wells, the producer, this producer. So I want to see what else we have here. So from the well object, we can extract cells, and there are some other stuff like the name that we already saw. You see, cell is it's actually a method, it's a function. This is an instance, and status as well. And you can set also the well visible in, or setting the visibility of a well in ResInsight from here straight away. So you can actually set what you want to see on the 3D from Python. But that's not what we want to show here. So I'm going to get some information. That's what we're trying to do here. So from the well and from the cells in particular for this particular well, and this function, because remember that we're talking about recurrent data. So we have to specify which time step we are in, yes? And to specify which time step we are in, I think above. So we can say, well, there are a number of time steps, and the well, of course, can be completed in over time. You can do a workover and go to a different formation. So the connections for over time will change on the well, and this is stored on the well item. So that's why you need to specify the time step. So I want to get only the information at the very last time step. And as you can remember from we have the time steps here already stored. So I can get the number of time steps, which is the length of time steps. So now watch this, because this is going to fail, and I'll show you why. And this is very important that you understand on the philosophy of ResInsight and Python. I'm going to make it fail, and let's extract the information of the IJK. Before we do that, let's just print. Let's just print this. Let's see if we can print this. I believe that this is something that is not printable, but let's see if we can do that. Yeah, that's not printable. And let's put end time step. So if I do that, oh, that sort of went through, didn't complain. That's fine, but something, it's empty here. And I believe that we have to specify, when we say the length of time steps, this is important. Python is referenced to 0. While ResInsight, obviously, if you have an IJK, there is no such thing as cell 000. There is a cell 111. So, but in the Python, when you're working with Python, everything is referenced to 0. So when you're calling index, you have to subtract 1 from the indices. And when you're calling time steps, you have to subtract 1 from the time step. So you take everything into the domain, into the Python domain, which is everything is referenced to 0. So you see here in the well cells, we have IJK, IJ, and over, we have, for the last time step, we have all the cells where the well is connected. 2939.6, 2939.7, it's a vertical well. It's connected there. And I can get, for instance, let's take I just want to get the well head. So I'm going to get item 0. And I want to get, as you can see, IJK, it's the object. This is a dictionary. And within that dictionary I can access by calling IJK, and I can call, let's say I want to call, for the sake of this example, only the cell I. Okay. Now I have here my index I of that well. Okay, very long, but now what I would like to do is have the I, J, oops. I would like to have a list of I, J, and K for all the wells. So now, let's forget about what I was printing here for a second. I'm going to make a comment here, and I would like to do cells I dot append, and we know that this is what we want to append. I want to append the I cell of the first cell of the last time step. So again, this is getting the first cell per well on the last time step. And I can do that for I, J and K. So a bit more of exploratory data analysis to see where the wells are, what is the top of the well at the end of the run. So I have here the name of a well. So let me print well names and print cells I, J, and K in different lines. That works. That's super fast, actually. And as I mentioned, we have zeros here. Let's see who's paying attention now. So why do we have zeros here? Anyone on the chat or anyone can answer the question. Why do we have zeros here? Are those correct? So if I see, is there any layer 0 on the, no, it's not the inactive blocks. It's not the inactive blocks. Anyone else? Any idea? No, pinch out. It's the domain. So Python is referencing all the points to see, they are all referenced to 0. So if I take, for instance, the first well, which is inch 005, let's see where is inch 005. Don't know this model. Where it is, inch 15, injector 15, 005, that's producer. Where are you? I'm gonna find another one. I don't see this. Perhaps it's not here. Let's take the second one, which is inch 006, which is here. So if we click on that cell, oh yeah, it was here, yeah. If you click on that cell, you see that it's 4721.1. That's the first cell, but it says 4621. Actually, let me see that again. 4721.1. Okay, actually. So what's happening there, and this is 3236.1, actually, the first one. 3236.1. So what you need to do in here is to take it to the real domain of the simulation domain, you have to add the 1. So in here, we took it to the Python domain by subtracting 1, and in here, we take it back to the simulation domain by adding 1. That's all. That's all. Okay. Is that clear? Yes? Fine. So let's carry on. And now we are going to extract some 3D results. It's gonna get a bit more exciting, and we are running a bit out of time. So I'm going to do write this function very quick. So I want to extract the property of a given cell by giving a variable type. Let's say if we want to do dynamic or static, and I want to do the variable name, and I want to pass also the case. And so what I want to is to do, it's iterate over the multiple time steps. So I want to iterate over time steps in time step in time steps. I want to iterate over all the time steps. But I'm going to put a counter here. So I'm going to call it t_count. And to use a counter, I need to use an enumerate here. So when I'm iterating, I get the time steps, and I get the, similar to putting a counter at the top, but it's a bit more elegant. So what I want to store is all the dates in that enumeration, and I want to store the 3D results. So I want results 3D. Oops. And as I go forward, okay, let's store that. So from the dates, I'm just going to append to this day. Let me see what I would like to do. I would like to do exactly what I did here. So I just want to get the date of every time step. Sorry, so I want to get the date of every time step. So, and I'm going to use again datetime dot date. But now I'm going to use time step, just time step. So I go for every time step. So because this is extracting data from 3D results for each time step in given cells. That's what we want to do. And those given cells can be the ones that we have here at the top. That's what we want to do here. So the 3D results are, I'm going to extract from the case. I'm going to extract the grid property. And this function, the way the function works, it's you need to specify the variable type, which is in this case whether if it's a dynamic or static, and you need to specify the variable name, and we're going to specify at which time step you want that variable. And I don't know why, but you have to set grid index equal to 0, and let's see if that works. Let's see. Actually, let's do it without this, just like that. Okay. So we have now the full 3D model. So let's say what I'm doing there at the moment, I have at every particular time step in this list, I can have the full values of whatever property I want, oil saturation, pressure, whatever property I want. But I want to get the ones at the top of the well. So what I want is to reproduce something similar to this. I want to do this, clicking here, and check whether, where are my properties, cell results. I want to get oil saturation. So if you see here, we should have a profile, oil saturation profile here. But what I'm trying to have is an oil saturation profile, just like this one. But now I want to extract that to Python, and I want to be able to extract that automatically. So, so I need to get the property value for the cell that I want. So the property value over time, let's store it here. So I'm going to copy this very quickly. I'm not going to bother you with a lot of this, with all the details of this function. But what I'm going to do here is for every cell in I, so I'm going to iterate for all these cells, and I'm going to extract the property on that cell index. I can calculate the cell index, and I'm going to create a matrix of properties. And what I'm going to do with that matrix is, as Adolfo mentioned, it's good to have everything into a NumPy arrays. So I'm going to convert that matrix into a NumPy array, and I'm going to store everything into a data frame. So this function will return my property, oil saturation, pressure, whatever, for all the time steps, for all the cells that I want. In this case, I'm going to iterate over all these cells. So for any particular reason, I want to get that information for all the wells. So what I'm going to do now is set up my variable type. As I mentioned at the beginning, we're talking about a dynamic underscore native. And also my variable name, it's I'm going to extract. What do you want to extract? Let's extract the pressure. And I'm going to store everything into my results. I'm going to call prop cells. Let me run this line. Hopefully that, oops, what's that? Results 3D. Oh, okay. I need to append. No, that was fine. In fact, I don't need this to be an array. And I think that what's happening here is that we need to provide some more values here. So we need to provide here results. I think we're missing this. Oh, sorry, we were missing a parenthesis there. Yeah, thank you, Roman, thank you. Yeah, the session is being recorded. Hopefully it should be working fine. So let me see if that works without all yeah, that works without all the additional information. And what I want to do, it's called prop cell. And I want to give my var type. And I want to give my var name. And just in case I want to iterate, I want to provide only case 0. Okay, the only case I have. So if I do as Adolfo mentioned, let's do results and let's do a head. And I want to see only the 10th or the 21st rows. And that wouldn't work. Why is it not working? Property values. Property values is not defined. Where is property values? Property values. Okay. Okay. Boom. The result prop cells. Local variable matrix reference before assignment. So I haven't created a matrix, empty matrix. And hopefully that is running.
Alejandro.
Yes.
A good rule of thumb, a good practice is always list. If you have a list, always use plural, right? Always. And you want individual elements, then you use the singular for individual element. That way you say property value in property values.
Oh, yes, yes, so yes. Well, that's what I was doing with time steps, no?
Yeah, yeah.
Yeah, yeah. That's what I was, cells as opposed to cell index within the, yes. So what's happening here now on the wells?
It's an index.
What's happening? The F results index of column wells. Oh, yes. So I wanted to get all the. So I want to assign to the name of the columns the well names. So actually, it shouldn't be wells. It should be well names. Did that work? Yes. What do I have here? We have similar to what Adolfo was showing, where you were extracting data from the summary files. Now we're extracting data from the from the grid, from the actual 3D grid. And this is a pressure distribution over time for every particular vector. So if I want to do oil saturation, that's my top 20 rows of oil saturation. Now, if I do a plot, let's produce a quick plot. And the plot, it's I can straight away do df results. Yes, dot plot, and I'm going to do a plot straight out of pandas. I can do the kind of plot I want to do, a line plot, similar to what you have in ResInsight. Let's see how that looks. There you go. That's awful. And let's do a bit of cosmetics. Bit of a bigger plot. Okay. So we have oil saturation over time. And I can do some more interesting things, like let's say I want to get multiple properties. So I have now let's say properties underscore 3D, and I want to get information for those cells for pressure, and I want to get information for oil saturation, and I want to get information for water saturation. And now I can wrap this into a for loop. So for property following the plural, the singular and plural recommendation from Adolfo in properties 3D. And I want to get this property. I want to run this. Call it here, and instead of var name, I'm going to call property 3D. So let's see if that works. So I should have a plot for pressure, for oil saturation, and for water saturation for those cells that we listed there. So this is my pressure distribution. That's metric units, by the way, over the dates, over time. That's oil saturation over time, and that's water saturation over time for the top cell of every well. So far so good. Let's do a couple of nice things up here. I'm going to add the title at the top, and I want this to be the name of that property 3D. And I want the grid to be shown as well. And while that is running, I think you get the idea of the power of using Python now with the simulation model. The thing is that I have written all this stuff, and this is not related to a single specific model. This is all independent of any model. So I can open any model in ResInsight, and I can run exactly the same code and do a quick exploratory data analysis on ResInsight on that model using the Python link. Now let's do something interesting. Now this is a static properties, and of course now we're going to set our var type. Let's change the var type to static. We have to remember that we have to call the native. And now I want to have a list of properties. And well, we have a list of properties already. These are the list of properties as we shown before. These are all the properties that we have in here. Okay. But what I want to do, it's let's say I want to take just some properties, and I don't know if this is going to work because I was trying in another model. But let's get porosity, perm X, perm Z, and I'm going to take net to gross, and I'm going to take also the critical water saturation. All right. So I'm going to take all those properties. And what I want to do is get that information from the cases. So if I go to cases 0, and I go to grid properties, the same function that we used before, grid underscore property, and now the var type that we're going to use, actually we can copy and paste if you want. We can. Where is that? This one that we use here. Same property, but now we are passing a static property. So var type, it's going to be static native. The var name, it's whatever I want to do. So I can, let's say I want to get the porosity. And if I want to print the porosity, okay, T count is not defined. Well, it's defined above. I don't know. I think it's nested into this function, and that's why we don't get it. But if I put T underscore or N underscore time T steps, let's see if that works. Okay, this is complaining, but this is a static property. So what time step do you think that I should be getting this from? Which time step should I use for static properties? Right, yeah, Roman, I got the 0. And it's computing or reading into Python, and I get all these matrix of, in this case, porosity. So I'm going to do something a bit more interesting here, and I'm going to do a for loop. So for every I'm going to use var name in the list of properties. The list of properties too. I'm going to get all the var names. And what I'm going to do is define a data frame where I can store all these properties. So I don't want to print this stuff. I just want to store everything into a data frame. So I'm going to call this data frame properties. And this is going to be just an empty data frame up to this point. But what I want to do is store all these values that you see here in every column of a data frame, so that I can do some further analysis in Python. So I'm going to add a column every time that I iterate over that loop. I'm going to add a column with the variable name, and store in this data frame. So what I have here, let's do the clean it bit. Let's see what we have. And I'm going to do describe the data so you see what's going on here. Okay, and I'm going to do something here. Perhaps I'm wrong, but and there are multiple ways in which you can do this. But as you can see, there are some infinite values that have been drawn from the data. In fact, if I take, those are from the inactive cells. So if I take the head, the first values, you see that everything is inactive. So that's pretty useless for us. So what I'm going to do, it's filter this. and I'm going to do the properties. There are multiple ways in which you can do this. The first step that I'm going to follow is just replace all those values by NAs. So I'm going to do np.inf because those are actually infinite values, non-pi infinite values. np.ana, not a number. And now I'm going to remove the F properties. I want to remove from the F properties. If I get, let's say I'm going to get porosity, and I can check if the values are not a number, and I want to keep all the values that have number. So I have to negate this. So pretty much I'm saying I don't want in my final data frame any value where porosity is not a number, right? And if I do describe again, see if that works. Oops, that didn't work. And describe the porosity is Na. Oh, what's this? There you go. So now let's see if a number makes sense. I have a minimum value of porosity of 0.018 and a max of 27.65%. Permeability max value of 482. And funny enough, permeability, set permeability, there doesn't seem to be a KV/KH ratio here. I have the residual oil saturation, and I have the critical water saturation. Fine. I like to use per plot in Seaborn. So if I do sns.perplot, it's very straightforward. So I can generate a histogram with cross plots for all the variables. So it's just saves a lot of time in data analysis. So let's see if that works. So it's doing something there. It's quite a lot of points. And while that is ongoing, okay, here we go. So now we have a cross plot of porosity. We have, first of all, the histogram for all the variables, porosity, perm X, perm Z. We have extreme values of the oil, the residual oil saturation, and extreme values of the critical water saturation. I can try to get something else. I don't know if it's going to work. It didn't work before in a different data, but if I add a color, for instance, for the SATNUM, let's say if I have a property SATNUM here. In fact, I won't do that because we are running out of time, and there's still a couple of more things that I want to show. So this is an interactive selection in ResInsight. I'm just gonna copy the whole code, and I'm not going to show you all the steps here because otherwise you won't stay here that long. But the idea is now let's explore how can I get information from what I am selecting on ResInsight. So this is similar to what we did before, but now the cells that I'm selecting, it's from the case that is inside ResInsight. And so I have this model here. So far, if I select, let's say I select this well, And you can see that I have oil saturation there. You can see the plot of oil saturation. And what I wanted to reproduce is exactly what we have here. It's this plot. But now if this is nested into a function, you can imagine looping into this function and adding many more properties, and almost like preparing your own dashboard when you can do analysis of the properties. So if I run this, there we go. It's exactly the same plot as we have here. So as we add more cells, and if I run this, oh yeah, see, it's the same plot, yeah, as we have. Now the difference is now you have the interactivity with ResInsight, where you are selecting properties, and you can imagine also bringing multiple models. And if you want to request the same data for multiple realizations, you can load those multiple realizations, iterate over all those models, and make a comparison of particular cell values in those realizations. Let's say you are having a look at a polymer flooding scenario, and you want to see what is the concentration of a polymer here, and because you have a tracer tracking, or if it's getting into the well at a particular date in different realizations, then you can run this for the multiple models rather than having just one case. I have case 0. You can have multiple cases and then have a plot for that, for the, let's say, for the concentration of a polymer or a surfactant or any particular agent that you're injecting into your model over many realizations. Okay, and a bit interesting as well. You can do calculated properties here. This is not really. You can write your own scripts and calculate properties here, and you can also do the same here. So, and actually, if I in this script that I'm copying and pasting, I am just calculating the height. I'm taking the dx, the porosity, the oil saturation, and I'm calculating the high physo, which is a property to almost estimate what is the quality of your cell. And I want to calculate that property at the end of the time step only. And so if you run that, if you see this now, there is in the generated property, there is my high physo property. And this property is a calculated property now that you calculated it in Python, you stored it into a NumPy array, and now you set the active cell properties to that particular high physo property in the last time step. I put here the last time step. So if I put time step 0, you could see that if I change to, let's say, to another time step, there is nothing. That property is nowhere. So it's only on the first time step and on the first time step and on the last time step. The rest of the time steps, there is nothing there. So just be careful where you want to store your property, because time step is also required. And this is super. The last one, it's super nice, and it piggybacks to what Adolfo was doing. And I really like these workflows of multiple realizations, and I like to run as many simulation cases as I can. What I'm going to do here, I have a bunch of models. They are not even in ResInsight. As you can see, ResInsight, there is only one model here, and there is nothing really. There is only one model here. And what I'm going to do is get a bunch of models. Those models, they have this name. I'm going to get 72 models. So if I show you what I'm trying to do here, it's just creating a list of simulation cases that I want to bring to Jupyter. So I want to bring 72 models, and just not to bother you with so much coding. And now, as we are running out of time, or I'm running out of time here. So what I'm going to do, it's I want to get, for this model, this is a SPE1 simulation model. I'll show you that in a bit. We have, Adolfo and I, we had a presentation, a training that we provided through the SPE in Houston, where we took the SPE1 and some other simulation cases, and we go back to basics in simulation. I don't know if you have a feeling that that when you are going through these trainings, simulation trainings, what you are actually learning, it's almost how to use the tools rather than what is actually you are able to do with the simulation. So in these trainings, we have been doing, go back to the basics of the simulation, changing the resolution, changing compressibility values, properties, changing with geostatistics, the properties like homogeneous, heterogeneous, the orientation of the properties, and so on. What we do is do a comparison of what is the actual effect of doing this in the simulation model. And we're calling this almost the lost art of reservoir simulation, because all the reservoir simulation engineers, they just jump into the model and they just produce something out of any tool. I'm not going to mention commercial tools. They run the model, and then you don't think too much about whether your grid resolution is right, or whether you have the properties, how sensible are the properties that you are introducing, and so on. So that's why we have that training. So this is from SPE1. And what we do, I'm going to get all the results from sensitivities that we have done in SPE1, and we'll see that in a bit. And this is, again, running bringing the vectors of bottom hole pressure and well oil production rate for, in this case, for, I think, only one well for the producer. And what I want to do is now bring that result back into Jupyter. And do a plot with matplotlib. So it's working on the background, and this is also why we have, you see at the bottom, it's flickering, it's loading all these applications, and this is why we also have our own our own summary readers for consulting, because if you're sometimes we work with hundreds of models, and you want this to be as quick as possible. I mean, that's fine, it's doing the work. But at some point, ResInsight, in a real case, if you're running 100 cases, you're going to run out of memory. So let's wait until it finishes to load all those cases. And what we should see, it's a bottom hole pressure and oil production rate plot. And here, I'm only importing the summary cases. So here you have for the oil the product producer, we have I think what we have is oil production rate. So it's flatlining, pretty much producing for most of the cases, it's producing at 20,000. I believe I don't remember the units of this case, but it's I believe it should be barrels, and yeah, barrels, and it's all field units. So we have PSI, and we have a pressure behavior for all the cases. And what we were teaching in that particular course is that there is a relationship of these profiles and to the behavior that you have on the well, based on in this particular example, I think it was a great example 3. It was how heterogeneous or homogeneous, or the orientation of properties, and also the variability of the properties, and how could it greatly affect your simulation results. And at some point, you have some models that actually are not able to produce at the highest potential rate, but they go into bottom hole pressure control. So that's it that we have so far for ResInsight. I think it was plenty, and let's finish up with that example, and let's open up for questions. So you could ask whether this is compatible with Eclipse outputs, and yes. Yes, and these examples are going to be published in Orca Hub. Yes, Jiku. And what I explained the last bit. It's what you can do with multiple realizations. As I mentioned on this particular model, for instance, I only loaded in ResInsight. You can see that I have from Python. I loaded all my realizations, and I can pretty much turn on all the realizations and plot any particular plot. And I don't know what's happening here, but I can turn on some plots. Let's turn all the realizations, and let's turn, for instance, bottom hole pressure, which is what I was showing there, and for the producer, right? So this is exactly the same plot. The point being is that you can prepare your dashboard in Jupyter, and you don't have to really worry too much about going into ResInsight if you don't need to. The GUI needs to be open at all times when using RIPs. I believe that is the case. And oh yeah, that's a comment, Adolfo. Yes. Thanks for. Have you tried Evolve simulation model? Yes, and in the last session, in the session that we have planned for this date, we're going to go do an exploratory data analysis for the general information for both production data, probably load some relative permeability, some information there, and but then we'll do the same thing, similar things with both. There is also an RMS geological model involved. Yes, no, the RMS model cannot be viewed on ResInsight. ResInsight is only simulation models, so you need a grid, Eclipse eGrid, Eclipse format, and the SM spec or summary results from Eclipse. And it's very interesting questions. Let me see if there is any other. If it's possible to interact with Python from. Oh yeah, that's what Roman was asking. Anything else? Am I missing anything? Have we answered all the questions, or at least address the questions that you have on the chat? Or if anyone wants to ask the question with the mic on, everyone is welcome. I think you are all on mute at the moment if you want to ask something.
Yeah, it's important that you explore yourself these examples and try to see what else you can do, because these things are kind of advanced applications. But the magic of Python is that you can do advanced stuff, with very little effort. But practice, nothing can replace practice. So you can imagine all this analysis and data exploration that you can do thanks to the API that they provide. But this is what is happening with Python. Everybody is providing a Python API to their tools. There are so many open source tools, plus all the Python ecosystem already existing, like a Pandas and NumPy, Matplotlib, and so on and so forth. The list is infinite. But definitely it's something that you need to explore hands-on. And also, that's the way we all learn. Alejandro and I do this all the time. So we discover something, we discuss. I don't know how to do this. He finds how to do it. I find something else. Imagine what we can do as a community if everybody is exploring the tools and sharing what they find. So So I think that's the power of this.
Yep. And also, if there is a question about what else if you can extract horizons, and so for you to have an idea, there is a link to the API, Python API. By the way, this has worked flawless in a way here, but when we work with it and we have crashes. So this is not perfect, and we are not in any of these sessions, we are not saying, oh, you should use this for your work. We are just highlighting tools that we see that may have value for your work or your studies. But we have faced issues and crashes with the application. So bear in mind that would happen, and also make sure that when you're working, there is a message box here, and you have to have a server listening on here. If you don't have a server listening, it's not going to work. So just bear that in mind. So you need to have the application open. So for there are many examples here, and to be honest, we struggle with these examples, and I think it's some are good, some others are tough to follow up. There is a question about Roman asked whether if it's possible to extract horizons, and there is this example of exporting contour maps, and let's see how that works on this. This is risky, but let's see how that works. Number of Eclipse contour maps. I don't know what would that do. Seems to be running, but I would have to check. I think that's a contour map probably for properties. And oh, you are actually finding contour maps that are in the I don't think it's extracting from the model. I think probably from Octave you can do more of that stuff, and I think they are slowly integrating more and more of a Python, more of a full API functionalities connected to Python. And what else? Before I move away as well, there is also the package here. If you have a look, there are some information on how this every method is implemented and how you should use every particular method. It's pretty much a manual rather than a tutorial. So you should go into the Python examples to see how some examples, but I believe not everything is well covered there, and we really struggle to actually put this together. We spend good amount of time to make sure that we have a demo that could work and show something meaningful. I think to me some of these examples didn't resonate too much, but that's up to you to have a look. Lots of questions, slightly off topic. Mentioned that we tested an API on Linux machine. Which distribution? They only have packages. I don't know. I don't know about that. I haven't tested. I was Windows. I thought that Adolfo may because Adolfo have been working with ResInsight a lot in Linux, but I don't know if he particularly tested this in Linux. Adolfo, the API, the web app connection, web server connection.
Yeah, I did compile ResInsight on Linux. That's how I started working with this. But I never tested the API. I assume it should work fine, but I've never tested it, and I need to check if my Linux installation is up to date. But that's what I've been doing. I keep updating my clone, compiling, but that can be a they make it relatively easy to compile, but it's not simple. It's not simple because there are many dependencies, so you have to compile in certain order. Probably they have improved it, but and when I started working with the ResInsight, that actually was the only way to work on Linux. I'm not sure if they are distributing a binary. I guess somebody mentioned for Debian. Yeah.
I'm not sure.
Yeah, it can be compiled. It can be a lot of work, but it's worth it. You will learn something.
Yeah, exactly.
Sure. Yeah.
Jiku is playing devil's advocate and saying whether if I have Office or Flowis and all this stuff, what I use is Jiku. I do consultancy and I have been with client. I had a client that and I've been working with operators as well and service companies. And I had a client that I was providing services for years, and I had access to Petrel, Eclipse Office, Flowis, and so many other tools. And at the time I wrote a lot of code to be able to do more myself. And this is what the message of all these sessions is. Yes, you may have, this is not about replacing tools. This is about enhancing your workflows. Go ahead of what you can actually do in some of these tools, or exploit more the value. So again, all this stuff that I did in a Jupyter notebook, if I open any other case, that would work, and I can almost produce a dashboard for exploratory data analysis of that particular case. That would take me a lot of time to go into a commercial tool and go to all these bits of cases, probably do some print screens, save it in a PowerPoint, and so on. With Python, I can even export these images straight to PowerPoint for any simulation case that I do. And I can bypass all these tools to get, for instance, summary results straight into Excels and do some economics if I want. And that's really the power. The power is not replacing what you actually can do now. The power is enhancing what you are able to do now with the tools that are available in the market. That's really the power, to me at least. Well, I think that's it. We have really gone well beyond 2 hours, and thanks everyone for joining. And this is very close to my heart and Adolfo's heart. Working with reservoir simulation, it's what we like to do the most, and we're really glad that a lot of people joined. We have over 30 people now. We have 20 that managed to stay. But yeah, thanks all for joining on a Sunday. I know it's difficult, but thank you, everyone.
Yeah, thank you for attending, everyone.
Thank you, great session.
Thank you, Aki.